Our number one goal as future engineers, besides making money, is to improve the planet for us and for others. It's true we cannot fix everything that is wrong in our planet, but we can start by making a difference in someone else's life. One way our group decided to do this is by proposing a way to fix the problem of landfills in the Caribbean and specifically in Jamaica. Landfills are pretty ugly sites, and it's not just the amount of waste that is accumulating in these places, but it's the problem that causes, such as toxins and greenhouse gases.
The gasification plant is ideal for Jamaica's landfill issue for a number of reasons. It allows the country to start towards eliminating the use of landfills or dumps as waste management, in turn increasing the well-being of its residents as the quality of air, water, and land improve. Currently, over 90% of the country's energy production is dependent on imported fossil fuels and petroleum. This is directly correlated to the high cost of electricity. Having this plant local would allow for significant cost savings in utilities.
Some of the processes or technologies that we consider to reach our project objective are treating municipal solid waste into energy, or various forms of gasification, pyrolysis, or thermal depolymerization. Ultimately, we went with a circulating fluidized bed, or CFB, gasification for multiple reasons. One of those main reasons being that it can treat multiple types of waste coming into our plant, such as tars, heavy metals, organic chemicals, and more beyond just typical compost and plastics. Another reason why we chose it was because that the feedstock coming in doesn't have to be treated as much as other plants do, and because of that, that can keep our costs down. We chose CFB over other options because of just like it has a lot more information about it. It's slightly cheaper, such as plasma arc gasification, which was our second option that we considered. But because of plasma arc gasification needing such high startup and upkeep costs, that we just ultimately disregarded it in the end.
Gasification begins by pre-processing municipal solid waste and removing metals, glasses, and plastics, and preparing the biomass to be fed to the circulating fluidized bed. The CFB operates at temperatures greater than 800 degrees Celsius and requires steam, small amounts of oxygen to not fully oxidize, to produce raw forms of syngas and slag. Some of the gases produced are flue gases, which are taken care of, and the syngas is cleaned. The clean syngas could later be used to produce electricity through various power generation methods. The steam is then used in a simple heat exchanger to initially start up the CFB. Here is a more detailed description of how the circulating fluidized bed works, in which biomass and steam are fed into a gasifier. Gasifier then gives fuel to the combustor, which requires small amounts of oxygen to combust and produce slag and ash and flue gas. Some of the heat is given back to the gasifier to produce the required syngas. Here is a more detailed rendering of the process.
For our design constraints, the most important categories are technical, economic, environmental, and finally social constraints. For our technical constraints, we are required to capture and treat any formation or releases of tars, heavy metals, halogens, or any other compounds. Our process also should be able to utilize all types of municipal solid waste. For social constraints, we should be able to get the land away from our plant, so the tourism industry should be happy. For environmental constraint, our process plant should be able to keep total collective waste under control.
Some of the factors affecting the profitability are operating costs, startup costs, as well as unexpected costs. We expect to see a positive profit margin over the years as we compete with already high electricity costs and use low-cost feed.
Availability and cost of land are some of the unknowns that will need further research moving forward.